Okay, so already recording has started. So first I shall mention the setup, right? You see here, this is the experiment for calibration of energy meter, and we have a couple of things here. You see here, this is the, you see here, this is standard meter. On the left side, middle there is test meter, and in right side there is couple of loads. Okay, and we have watt meter to measure power, and separately we have ammeters and voltmeters, right? So this is the whole configurations, and this is the power supply on the IAC is there. Okay, and experiment number is 4, and we have done the initial connections, and I'm going to conduct two tests, long time test and short time test. So first we will go for short time test. So do you know the purpose of short time test? Anyone? The purpose of short time test, do you know? Okay, let me share my screen and then tell these things. Can you see my screen right now?
Yes, sir. Yes, sir.
Yes, sir.
Yeah. So the objective of short time test is to find the speed error, and objective of long time test is to find the registration error, right? So in 2 hours it is not possible to conduct the third part, like to compare the calibration of meters with the help of relation energy meters. So this is not possible to complete, so I'll be focusing only on these two parts, short time test and long time test, right? So this is the diagram, means sketch of energy meters, and this is the coil uh, called pressure coil where voltage is provided, and this is the coil to provide current, and I call it current coil. So because of a torque, this aluminum disc rotates, and we get, if we increase the load, maybe voltage or current, okay, we can see that the rotation will be in the faster way. Okay, so rotation is proportional to voltage and current, right? So if we compute the power will be, means power we can represent in terms of watt, and time in seconds. So standard reading will be P into T joules. Okay, so this we can see from the standard meter in the left side. Similarly, in the same way we can find out, we can put on the load and switch on the load, and count the number of rotations of the disk. Think of this is n, and meter constant is already provided in the manual, so I can tell the values of k. So we can get the test reading using the formula n by k, kilowatt hour. So I'm converting to joules, that's why multiplying by 3600, that is basically, tell me please.
So what is meant by meter constant?
Oh, this is some parameter or constant of energy meter, right? And we shall provide the values, don't worry. Okay. This is given by the manufacturer. So test reading is n by k, and this is kilowatt hour. I'm converting to joules. That's why I'm multiplying 3600,000. Okay, this is to convert to second, and this is to convert to simple joules. Okay, because k is there, kilowatt is there. That's why this kind of multiplication is required to get in joules. Now you can get the percentage error or disk error by this formula: test error minus standard error divided by standard error into 100 in terms of percentage. Okay. So for long, this is about the short-term test. So we can vary the loads and see the number n for different load conditions, and we can get average about these different setups. Okay. In this way, you can find out the average percentage error. Okay. And long-term test, actually, formula is a bit different. So we'll note down the initial reading of energy meters, and then we'll run these things full load conditions around 20 minutes, and we know the final readings. So test reading will be final reading minus initial readings. Okay. Uh, so then you can find out the percentage error in the same formula. Okay. So that's all about because you see test reading minus standard reading by standard reading is the formula of percentage error. So you already got the test readings, and you can easily compute the standard reading by the formula P into T joules. Okay, because we have provided one watt meter to measure the P, and we have stopwatch to count the time T. Okay, so we can easily find out test readings, and by same formula we can find out the percentage error. Okay, so that's all about the experiment and the formula, all these things. Now come to table. Okay, circuit diagrams.
Sir, one thing. Sir, can you explain the physical significance of this formula percentage error? Like how it calculates the percentage physically? What is the significance?
Which one?
Sir, the percentage error one, the test reading minus standard reading by standard reading. How are we actually calculating percentage?
See, because of some error in instrument, there must be some error between the standard and the measured one. That's why we are going to measure the percentage error. That's all. It is true for all cases, okay? Not only energy meters. In measurement, you will never get the actual things which you should get, right? That's why this kind of error comes. So test reading, standard readings, and the standard readings in terms of percentage, 100. So this is the formula, common formula. Okay.
Sir, so why it is not test reading by standard reading into 100? Why are we subtracting it with standard by standard?
Well, you can error could be plus, could be minus. You can take absolute value, no problem.
Sir, what is meant by registration error, sir, in the long time test?
Long time. What is the questions?
What is meant by registration error? We know speed error. What is meant by registration error?
See, registration error. This is the formula basically. There is no. This is the way to compute. Okay.
No, sir, not formula. What is mean by the registration error means? What does that mean?
Registration error. I can discuss a couple of minutes later, right? The actual significance. Okay. After the experiment. But let me conduct the first experiment. This short-term test. Then I mention these things. Okay. So now tell me, in the circuit diagrams, is it possible to understand all these things, or I should explain these things?
Understandable.
See, this is the supply voltage, right? Variac. As I mentioned, variac I have in the left side. Have you seen the variac physically anytime? See, this is the variac. Can you see?
No, sir.
Can you see properly? Hello?
Sir.
Yes or no?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
And we can vary the supply voltage, right? And this is the watt meter. This left one is the watt meter, and the ammeter potential is already know. That's all. Okay. You see here, this is the watt meter. So supply is coming from here, and you are going to measure the power. And this is the meter. And hello. Yeah, this is a different kind of load basically. Okay. So in circuit diagram, we shall conduct right now. So we have three bulbs, right? We can consider these three loads here. Okay. So we'll just provide the first we'll just switch on any one of the bulb and we will count the number of rotations of the disc, fix it 10. Then we will repeat the same thing for two bulbs, that is two loads, for three bulbs, that is three loads. Okay, and we will compute the disc error for three sets, and then we shall do average. Okay, understand the procedure?
Why we have used 2 voltmeter here?
Where?
In figure 2, it is shown there are 2 wattmeter.
Here, in the circuit diagrams.
Yes, sir.
One is standard meter, no? And this is one watt meter. Okay, and we can measure the power in the watt meter and time by stopwatch, get the power, get the energy, and then we can take the difference. That how is the error? Okay.
Okay.
So our objective is to estimate the difference between the measurement of these two meters. That's all. Hello.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Now focus on the experimental reading. So have you gone through the table? So apparatus used, you can write all these things which I have shown it to you. The standard meter, test meter, and the loads, ammeter, voltmeter, all these things, and their range also can tell you. Range of wattmeter is 0 to 150. Range of ammeter is 1 to 2 ampere. Range of voltmeter is 1 to 300 volt. This is the range of all equipments we are using here. Okay. Yeah. So this is the table for short time test. So serial number 1, 2, 3 could be for serial number 1 or test case 1. You should note down the number of revolutions or rotations, and I can tell you the voltage, ammeters, all these things. So you can note down these readings, and you can easily compute the error. Okay. So in real time, we shall do everything. So let's see some of the things. Make it so for the information, we have set supply voltage 220. Can you please note down these things, the values? 220. Stopwatch. Rotations. Switch on, on. So we are switching on the circuit load, and we are counting number of rotation, 10 rotations. Okay, and the time for this. Stop. You please note down number of revolution for the first set of experiment for the first load. It is 10, and time taken 1 minute. Yeah, you can think of 64 seconds. Okay, note down. Are you noting these things, all of you?
Sir,
Yes,
please
sir.
time
Yes,
64.
sir.
Yeah. So I repeat again. Uh, Serial number 1, number of revolution big N equals to 10, and time taken 64 seconds. Okay, and the voltmeter reading 220, ammeter reading 0.72 ampere, and reading of wattmeter is 82 watt. Oh, there is some cost 82 into 2. Yeah, 2 is multiplying factor, so 82 into 2.
Sir, what is the time taken?
Uh, Time taken is 64 seconds, right?
Sir, multiplication
64.
factor is it 2 or 4?
Okay.
Sir, but the one which you given in the experiment 4 readings, it is 92 into 4. It is showing multiplication factor 4, sir. Now it is 2. How?
Watt or 92 watt?
Which one you were telling for?
Sir, for the multiplication factor once tell sir, it is 2 or 4.
Actually, yeah, it depends, no, on the watt meters. For this configuration of setting, and the multiplying factor is 2. So 82 into 2. You can note down these things. Okay.
Okay, sir.
Just hold. Yeah. Just hold on. Couple of things, and we will continue again.
Sir, you are not audible, sir.
Yes, value of k, we found it 3600. Can you please check the error, how much it is coming?
Sir, can you repeat what you said, sir?
I mentioned that values of k, because if you look the formula, there is some constant k, right? Values of k is 3600. 3600. See, to get the test reading, no, you already measured n, but I should tell the values of k. We found from the manual values of k is 3600. Now compute the error from the table as I mentioned for this case. Okay. For the first case. Time
Sir,
60.
what was the case, sir?
Sir, can you for the last time repeat the readings?
I mentioned 2 times.
Yes, sir.
I repeating again.
Sir, what is the?
We have to take reading again, no? Because your friends may be noted. So can you please tell number of revolution n? Voltage is 220. Ammeter reading was I think 0.72. Right. And odometer reading was
82 into 2.
82 into 2.
82.
perfect. Perfect.
Sir,
Perfect.
but we will write
Sir,
in
is it sir 4.72%?
or standard reading. Energy.
What?
Sir, but we will write in energy recorded.
No. See, listen. So to find out the percentage error, you only need test reading and standard reading, right?
Yes, sir.
What is standard reading? P into T joules. So you can easily compute. You can easily compute the test readings. Okay. So you can easily compute the error. So energy recorded.
Coming in negative, minus 4.96.
Error should be absolute. Just take the absolute value. Right.
Okay.
How much it is coming?
4.96%.
Sir, 4.72%. Sir.
All of you?
So 1 minute 4 seconds. So 4.72%.
Okay. So all of you agree with me or your friends? 4 point?
72, I think.
Okay. Okay. Then we can do the next experiment, next set. Okay. So give me some time to change the load. Then I am telling you. Okay.
Leave energy recorded blank because there is nothing to write in energy recorded column.
I'll come to these things. Then I first change. Give me 2 minutes to change the load, and then I will again come to you. Right. Hello. Yeah. Actually, there was some problem in the wattmeter, so we have fixed this. We have changed it to a different wattmeter, and now it's working fine because earlier it was unstable, and now it's stable now. Yeah. So you asked me that that this table about this table energy recorded, right? So you already seen that this is the power P I am getting using wattmeter. T is the time. So if you multiply P into T, this is the energy recorded. Okay. So this will come here.
So we have to write standard reading in that,
Where?
in energy recorded. I got that.
Yeah, yeah.
Okay.
So that's all basically.
And sir,
So
one doubt. Sir, power is also V into I, sir. So what does that give? What is that power?
see, what I am doing here, tell me. What is the significance of the experiment? Tell me. I have one energy meter. Think of your in your house or flat or residence has some consume in your house, right? So think of this is my standard energy meter. Have I switched on my video? Just a minute. Yes. So think of this is my standard energy meter, right? This one in my house, right? So whether it is working fine or not, what is the way to check? For some interval, for some load, and I can measure the power consumed by some wattmeter. Okay, and I can note down the time. So if I multiply power versus time, I can also get the energy, and I can easily check that whether my energy meter in the house is perfect or not. Okay, so this kind of calibration is basically things basically.
Sir, your video is actually freezing sometime.
And your voice is also cracking sometimes.
Actually, I am using the Wi-Fi in the lab, no. So I am using the high-end camera. Okay, so I am not using my mobile camera actually. So, sorry, laptop camera. I am using a different camera to show you the setup properly. So that is the maximum performance of the camera and voice I can provide using the network. But I hope camera is fine, right? Can you see properly this thing?
Sir, your voice is breaking in between.
Okay, don't know. Yeah, but now it's clear.
Yes, sir.
Yes,
Okay.
sir.
Yeah. Now
Yeah, sir.
we are noting the second reading, right? So we are means giving two loads and counting the rotation, 10 rotations, and measuring the voltage, ampere and watt, and then we are computing the energy recorded. Okay. Just set everything. Voltage. No. It should be 220. So, take time. Check. Okay. So, can you see properly? So, right now, voltage is 220 and we are counting 10 rotation corresponding time, right? with different load. Okay. So so we are counting the time for 10 rotations in the change load.
Sir, can you resize your video to the full screen mode so that we can see it better?
Actually in full screen mode.
Sir, highlight your video, sir. Highlight your video. Right click and highlight, sir.
Yes, sir.
Spotlight, spotlight. Yes, sir, spotlight.
Spotlight for everyone. Can't you see properly?
Yes, sir.
Yes, sir. Yes, sir. Fine, fine, sir.
Okay. Yes, so note down the reading. So the change, can you see here? We have used two lights here. So just note down the readings and tell me the change. So your big N is 10 and voltage I mentioned it is 220 and current is current is 1.14 and yeah, reading of voltmeter is 64 into 4 because we have a different voltmeter right now. So constant is 4. Okay. So you compute and tell me.
And sir, time?
Yes, sir. Time.
Time is 36.2 seconds. Okay.
Sir, number of revolutions 10, right?
10.
So value of K 3600. Value of K.
K is fixed. 3600.
7.9%.
Okay. So you see here, if we change the load, then
That's 7.32%.
yeah. So what is the observation here from the readings?
When we increase the resistance, percentage error will increase.
Is it true always? Okay. Whatever you notice, you just write in the observation table. Yeah. So now we are going for another set of readings. We are changing load again. Okay. So let's switch on the third one. Yeah. Okay. Note down for 10 readings. So one more thing you already observed. You see that time is less for 10 revolution, right?
Yes.
Your second readings. Okay. So for the third reading, we are for the third case we are taking the count and time, all these things. Okay, so you had a question that what is the physical significance of this kind of experiment, right? Or the disk error, why you are doing these things. So from the
So your voice is lacking.
see, I wish to tell you that from can you draw some inference or conclusion?
So your voice again lacks.
We are not able to hear you.
The Wi-Fi in the laboratory. Okay. So anyway, third reading. Yeah. So note down for the third reading. Supply voltage 220. Current is 1.54. Reading of voltmeter is 85 into 4. I repeat again. N is 10. Supply voltage 220. Current is 1.54 ampere. And reading of voltmeter is 85 into 4.
Time, sir.
Time is 29.8 seconds. Now compute the error.
It's 1.32%.
1.32%. Okay. So if we average over three data, how much it is coming?
Sir, 4.73%.
Yeah. So if the percentage error is below 10%, so it's we can think it's acceptable. Okay. So I hope your result is fine now. Okay. So that's all about the first part of experiment. Okay. So
Those the boxes calibrated on the circuit board behind you. Show us
yeah.
the elements of the circuit board also and explain them. Means
Number EE/51/04. Okay.
so you are not audible.
Experiment number is EE/51/04. I can write here. Yeah. Got these things? This is the experiment number.
Can you explain
Bolo?
which is used to get the text reading? Which means used to
What?
sir,
See,
please.
I don't understand your question. You can write just experiment number 4. That's sufficient. No need to write these long things. Experiment 4. That's sufficient to me. Okay. Any
Sir,
more
I want
question?
to ask. It is the elements behind you that is calibrated on that circuit board. which is used to get the test reading. Can you show that?
Oh, test reading.
Sir, there are two boxes. I am not able to get the use of those two boxes.
Standard meter. Okay, standard meter is required basically for the third part of the experiment. Okay, but third part we are not dealing with. Okay, there is two watt there is two meter, right? Two energy meter. You can see here.
Yes, sir.
Yeah, we are using the middle one. Test meter we are using.
Okay.
That's all.
Okay.
I already mentioned these things earlier. Anyway, so finally you got average error of 4 point something, right? Of disk error. Okay. So can you please tell me what is the potential source of this disk error? Why such kind of error happens actually?
So some problem in disk, like in rotation, it is not perfectly rotating, so readings are not coming perfectly.
And because of temperature, I think so.
Just simple thing. Maybe some friction may cause some error, right, on the disk.
Yes, sir. Yes, sir.
That is the things. Okay, or you can simply tell the some error in the instrument. Okay, that's all. So now we are going for the second part, like long time test, table 2. Okay. So here actually we will allow this system to run for 5 minutes or so. Then we will just take the final readings, and at 0 point we will have initial reading. We will note these things. Let me show the couple of things here. In the energy meter, okay, can you see here something? Very small scale.
No, sir, it's not visible. Only the box is
Yes, sir.
visible.
And other things
Nothing.
like
Sir, please turn off
multiply.
the lamp. If you
Some
turn off the
lamp is
lamp, then
visible.
we'll be able to see. Turn off the lamp, sir.
Yeah, now can you see? I think you can see.
Yes, sir.
Yes, sir, they are so small.
Meter, okay. So what is their purpose? One is 1 by 1000, 1 by 10, then 1 multiplied by 10, multiplied by 100, multiplied by 1000. Okay. So what is
Okay.
their purpose?
To
See,
make the measurement precisable.
no.
Sir, to measure different
See,
amounts of energy, sir.
yeah, it's basically different scale you can think of, right? It's a
Yes,
different
sir, different
actually.
scales of energy.
Yeah, think of someone will be using this meter for 10 years. Okay, someone may use for 5 minutes, someone may use for 2 years, someone may use for 1 month. Then these different scales come into picture, right? So if for 10 years, if we use the 1 by 100 scale, will be mad. It's impossible, right? That's why some higher scale you have to use. That's all basically. So now I'll be strictly using for the experimental purpose 1 by 1000 the scale 1, and we will note down the initial reading, final reading, then we will compute the registration error, right? Yeah, let's switch on these things. So we are doing the experiment. Wait for 5 minutes, then we can tell the readings. Because we have to wait 5 minutes.
Sir, I want to ask a question. Sir, for
Tell me.
subsequent reading, time is decreasing. Why, sir? Sir, does it mean because the wattmeter reading means I am not able to get why time is decreasing for each subsequent reading when we are increasing the number of
Okay,
words?
okay. Actually, we have changed the load, no? Load has increased. In the first reading, load was low. If you look the power consumption, no, you will see that power is getting increased. That means this is happening because of increasing of load. Okay.
Sir, can you show the long time test table?
Yeah, I can show. The same circuit diagram, but just we are not counting the number of revolutions. We are just waiting for 5 minutes, and we see that reading is getting changed actually. That's all. Means if you see the meter 1/100, we actually noted the initial reading 7, but now it is going to 9. So we'll be noting these things. And we will wait for 5 minutes and we will see the final readings of the leftmost meter, the down. Okay. That's all, and we have 3 load here. And the meters are as usual. Watt meter, voltmeters, and meters.
Are connected in parallel or series?
Huh?
These loads are connected in parallel or series?
Have you seen the circuit?
I think they are connected in parallel.
Yeah, obviously. It is parallel. So that is the circuit. The circuit diagram is same for two cases, right?
Sir, in standard reading, wattmeter reading into time, why are we dividing it by 60?
There. See, if I am sharing the manual, tell
Sir,
me.
in the formula. Yes.
Tell me.
Yes, sir. In the long time test, the table, sir, the observation table. Yes, sir. Sir, why are we dividing it by 60?
Ignore this formula. I shall tell you a simplified formula. Okay, just note the readings. Okay.
Okay, sir.
Yeah. So note down the initial reading 7 into okay. So note down the initial reading is 7 and final is 10. Okay. So actual difference is final minus initial, so 3 multiplied by 1 by 100, 3 multiplied by 1 by 100 multiplied by 3600 multiplied by 1000. This will be in Joule.
Sir, we have to calculate in watt or in joule?
1 by 100, sir.
Sir, we have to calculate in watt or in joule?
In the meter. So that's why I'm using multiplying by 1 by 100. I'm using the smallest scale here. It's a scaling constant you can think of. So difference minus difference multiplied by scaling constant, then the conversion parameters like 3600, then 1000. So you are doing these things basically.
Sir,
So
but
then
the reading will be in joule, but test reading here it is written in watt, sir.
no, it is no, it is. So you are basically getting the error, no? So error don't have any unit, right? So you both of you can get in joule and then subtract, right? Does error have some error unit? No, right? So it doesn't matter.
Sir, why are we dividing by 100?
I already mentioned we are using a scale which is the smallest one. So that's why I am using 1 by 100. Because as you are using the 5 minutes time, no, there will not be sufficient change in the other scale, actual
Yes, sir.
scale. That's why I am using some lower scale, like to measure the distance between your home to playground. You cannot measure in millimeter, right? You have to use in meter or kilometers, right? In this way, from the same strategy, I am basically computing multiplying by 1 by 100. Okay.
Yes.
Any more question if you have?
What to write in wattmeter reading and time taken?
Time taken is 5 into 60 in second.
Watt meter reading?
Yeah, we can tell you. Uh, 85 watt reading.
And there is no multiplication factor, no? We have 85, simple 85. Or is there any multiplication factor?
Simple 85 into 4. Multiplying it is 4. Do you need to measure the current and voltage? No, right?
No, sir.
Okay. And time you know already I mentioned 5 into 60 second. Please give me the error, percentage error.
Sir, time once again, sir. Time.
I already mentioned it is 5 minutes. Convert to second, then get the standard reading W.
Sir, 5.88%.
How much?
Sir, 5.9% approximately.
Okay, that's fine. Do you wish to take another readings using a different load?
Yes, sir.
Yeah. Then we are switching on another. Yeah. Yeah, let's wait for 5 minutes more, and I ensure that all of your friends have the result, the same result.
Was it 5.88%, the first one?
Yes, 5.88%.
So reading for wattmeter is 64 into 4. Okay.
Sir, can you repeat the text reading part for long time test?
Mm-hmm.
Can you repeat the text reading part for long time test? Actually, my internet connection was lost, so I couldn't hear that part.
Oh, I forgot the data actually. Ask your friends. Can anyone tell him?
Sir, initial 7 and final 10. That's I read hard.
Yeah, yeah.
Uh, text reading is
Yeah.
108,000, that is in joules.
3000 watt, no? 10 minus 7 into 1000.
No, we are calculated in joules. So 3600 को multiply करना, तो final आ रहा है 108,000.
Then multiply. So 3 into 1 by 100 into 3600 into 1000. Okay.
Okay.
So test rating is 1080, right?
TSCD
108,000.
000.
No, actually error I remember. Please tell me the error. Final error. Okay.
Sir, yes, final error for the first one is 5.88%.
Yeah, that's fine. But second reading we are working on it. So let's just wait a couple of seconds. We will get the result. But I can tell you the reading of wattmeter is 64 into 4. Okay. Yeah. Please note down the time is 5 minutes. That is 5 into 3, 60 seconds. And this is how much? Initially it was 1.5, 3.5 or 4. 2.5. 2.5 means initial reading was 1.5. Okay. Then it is 4. So 4 minus 1.5 into 1 by 100 into 3600 into 1000. Okay. I repeat again. Initial is 1.5, final is 4. So final minus initial bracket 1 multiplied by 1 by 100 multiplied by 3600 multiplied by 100. So you can now find out the error and report the average error. So now tell me the error which you are getting. Complete.
Sir, it is coming a lot, like 17.18%, sir.
Yes, sir. 17.19. 17.19.
Yes, so much.
The 17.1%,
Actually,
sir, it is coming.
actually, final reading you can note 3.5 actually, because scale is very small, so it may be some parallax also. Make it 3.4 and then 1.5. Compute again.
Sir,
Sir,
3.5 final. Na?
Sir, please again tell the initial and final reading.
Initial was 1.5, then final is, you can note down 3.5 instead of 4. Okay. Then the others are same, so you can multiply.
So it is coming to 10.9.
Yeah, you note down this one because we had a parallax during observation. I have a doubt. That's why. Okay. So any further question regarding this?
So what is the K parameter, sir? So that we have used, sir, in first part of the program experiment.
Tell me.
So what is the K parameter, sir, that we have used in experiment first part?
Okay, so it's a parameter provided by supplier manufacturer.
Sir, for the second experiment, we don't have to use it. No?
It's different. Earlier we were using a number of turns, number of basically number of evaluations, but here we are not doing these things. Here we are basically completing the difference of final reading and initial readings. It's measuring, then you are completing.
Okay, sir. Okay, sir. Okay, sir. I get it, sir. I get it, sir. Thank you, sir.
So. Okay. If no questions, then I'm closing. Thank you so much for attending my classes. If you have any doubt in future, you are welcome to ask questions in email. Okay. Bye. See you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you,
sir.
Thank you,
Have a
sir.
nice day,
Take
sir.
care.
Thank you, sir.
Bye.
Thank you.
लास्ट का एरर क्या है सबका? अच्छा 10 टेस्ट रीडिंग क्या 90,000 जूल?
हाँ 90,000 আসছে। আচ্ছা
স্ট্যান্ডার্ড
স্ট্যান্ডার্ড
রিডিং
রিডিংটা কি হবে রে? স্ট্যান্ডার্ড রিডিংটা
46,080 জুল আসছে।
কত
76800.
কথা কেটে যাচ্ছে।
76800.
7680
अच्छा क्या किया तुम लोगों ने? 64 into 4 into 5 into 60 by 60 ना स्टैंडर्ड रीडिंग?
ना 60/60 করা কি দরকার?
अच्छा मतलब 5 into 60 सेकंड्स को मिनट में जैसा कि लिखा है।
नहीं बाय 60 नहीं करना पड़ेगा, जूल्स में निकल रहा है सर, वाट में नहीं निकला सर ने। और
नहीं
जूल
আরে
सर
বাংলায়
ने
বল।
तो अरे टाइम तो 5 मिनट ना তাহলে 64 into 4 into 5 64 into 5 into 5
আরে সেকেন্ডে ট্রান্সফর্ম করতে হবে, ওয়াটটা জুলে করলে সেকেন্ডে ট্রান্সফর্ম করতে হয় না, মিনিটে থোড়ি ট্রান্সফর্ম করিস, ওটাই ইনটু 60 করতে হবে।
मतलब 64 into 4 into 5 into 60
হ্যাঁ 300 সেকেন্ড হচ্ছে ওটাই। আর একটা জিনিস তো ফার্স্টে এরর গুলো কত আসছিল, ওগুলো আমার তো কম আসেনি, ওদের পার্সেন্টেজ 1.3 এসেছিল, 7.92 এসেছিল। তো তোরা সেকেন্ডে যেমন বলেছে স্যার 36.2, ওটা তো 36.2টাকে কি তোরা 2 বলতে তো 10 এ ডিভাইড করেছিলি না 60 তে ডিভাইড করেছিলি?
তো ডাইরেক্ট 36.2 সেকেন্ডে ইউজ করেছি।
হ্যাঁ তাহলে তো 7.92 আসছিল, ওর 7.8 সামথিং এসেছিল মনে হয়, এই যায় না
7.9 সেকেন্ডেরটা 7.9 এসেছিল আর
হ্যাঁ 7.92 আর লাস্টেরটা 1.3।
হ্যাঁ হ্যাঁ
1.30, ওটা 1.32 এসেছিল, কে থাক
1.30 এসেছিল। আচ্ছা দাদা এটা লাস্টেরটা 64 into 4 into 300 না?
হ্যাঁ 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 হ্যাঁ
হ্যাঁ তো মাইনাস অ্যানসারটা বেরাবে না?
মাইনাস তো এটা মড নিতে হয়, মাইনাস তো সাথে
আচ্ছা
মড
হ্যাঁ
পার্সেন্ট ইরর না, পার্সেন্ট ম্যাক্স তো ম্যাক্স করে নেব, ঠিক আছে।
স্যার ওখানে তাহলে বাই 60 কেন লেগেছে?
ওটা স্যার কিছু হয়তো ওয়ার্ডটা কিছু করেছে হয়তো, স্যার তো বলুন না, এটা করার দরকার নেই, ঠিক আছে।
আচ্ছা
বাই।
চল।